In the world of artificial intelligence, there's a war raging. But it's not a war of algorithms. It's a war of silicon. And right now, the two heavyweights, NVIDIA and Google, are in this incredible, explosive battle for hardware supremacy. So let's dive in and break this all down.
This is the headline that has been absolutely electrifying the tech world since early November 2025. The big claim here is that Google's new chip, codenamed Ironwood, has finally done the impossible. It's broken NVIDIA's decade-long stranglehold on AI compute.
But here's the million-dollar question. Is this for real? Is this a genuine power shift, or is it just the latest round of hype in a market that's, kind of defined by it? That's what we're tackling today. Is Google's challenger really about to dethrone the king?
Okay, so to really get to the bottom of this, to understand if a king can actually be dethroned, we first have to understand how they built their kingdom in the first place. This isn't just about two companies, it's about the entire evolution of computing.
You see this hourglass? It's the perfect way to think about the problem in AI right now. All the brilliant ideas, these massive models at the top, they can only move as fast as the hardware at the bottom allows. Today, the silicon, the chips themselves, dictate the pace of innovation for the entire industry.
All right, let's take a quick trip down memory lane. The history of AI hardware is really a story of specialization, of moving from these general-purpose tools to machines that are custom-built for one job.
For decades, the CPU was king. Think of it like a Swiss Army knife, pretty good at a lot of different things. Then, in 2006, NVIDIA's CUDA platform changed the game. It unlocked the power of GPUs, which are like these massive parallel factories, just perfect for the kind of math AI loves. And then, in 2016, Google introduced the TPU. That's an ASIC, which is basically a custom-built robot designed to do one single thing: AI math with unbelievable efficiency.
And that whole journey brings us right here to today's main event. In one corner, you've got the reigning champion, NVIDIA's Blackwell, and in the other corner, the highly specialized challenger, Google's Ironwood.
Blackwell is an absolute beast. Its biggest advantage is its flexibility. This isn't just an AI chip, it's an engine for AI, for high-performance computing, for scientific research, you name it. It's all backed by CUDA, which is the software ecosystem that, let's be honest, pretty much the entire industry runs on. And yeah, it boasts the highest peak performance out there, especially with its new transformer engine that supports this new format called FP4, which lets it crunch AI calculations faster and more efficiently than ever before.
Ironwood, though, it's playing a totally different sport. It's not trying to be a Swiss Army knife. It's a scalpel. It was engineered for one main purpose: inference. That's the part where an AI model is actually out in the wild, serving you, the user. Ironwood is built for insane efficiency, a lower total cost, and just absurd scalability. We're talking connecting over 9,000 chips into one giant supercomputer.
Now, when you put them side by side like this, you can really see their different philosophies. Sure, Blackwell's peak compute is higher, and memory specs look pretty similar. But look at those last two rows. That's where the story is. CUDA is universal. The TPU is locked into Google's cloud. And this other one, model flops utilization, or MFU, that's crucial. Think of it like a car's engine. You might have 500 horsepower, but how much of that power actually makes it to the wheels? Blackwell gets over 70% of its power on the road, while Ironwood is around 40%. But, and this is the key, Ironwood's biggest advantage isn't about raw specs, it's about total cost. And this chart, this is Ironwood's knockout punch. For companies serving massive AI models to millions of people, a potential 41% reduction in total cost of ownership is, well, it's monumental. We're not just talking about saving money. It's a strategic advantage that could open the door for new AI apps that were just too expensive to even think about before. This is the heart of that dethroning argument.
But here's the thing. This fight between NVIDIA and Google isn't happening in a vacuum. It's easy to get tunnel vision. So, to get the full picture, we really need to zoom out, because the entire market is changing under our feet. The reality is, the old idea of a single chip supplier is just shattering. I mean, look at this list. Amazon, Microsoft, Meta, nearly every major tech player is now building their own custom ASICs. The era of a one-size-fits-all solution is well and truly over. The market is fragmenting into 1,000 specialized pieces. So where does this all leave us? We've seen the champ, we've seen the challenger, we've seen this whole fragmented market. It brings us right back to our original question. who actually comes out on top?
So does Ironwood dethrone Blackwell? Honestly, that's just not the right way to look at it. The idea of a simple dethroning, this whole narrative, it kind of misses the bigger, much more interesting story that's unfolding. What we're really seeing isn't a replacement, it's an expansion. The past was defined by a GPU monopoly, one chip architecture for almost every single task. The future? It's a hybrid world. Companies are going to use powerful, flexible GPUs like Blackwell for the heavy lifting of cutting-edge research. But then, they'll deploy those models on hyper-efficient ASICs, like Ironwood, for large-scale, cost-effective inference. It's about using the right tool for the right job.
And that means the real winner of the AI chip war isn't NVIDIA, and it isn't Google. It's everyone else. It's us. This intense competition is driving down costs, it's giving us more options, and it's accelerating innovation for the entire AI ecosystem. Developers, startups, and you, the end user, we all benefit from this new hardware landscape.
And that just leaves us with one last thing to think about. As these AI data centers consume more and more of the world's electricity, maybe we've been measuring this whole race with the wrong yardstick. Maybe the next battle for dominance won't be fought over who has the most raw power, but who can deliver all that intelligence with the greatest efficiency.